Students, how are you? This is Ankit Joshi. Once again, welcome you all on India's largest e-learning platform, BYJU'S Exam Prep. Students, I just wanted to know whether I am audible or not. Is the audio and video all issues? Is there any issue? Please let me know. Audio, video सब ठीक है क्या? फटाफट बता दीजिए. और very quickly you should mark your attendance. I can see Yashwant. Good evening. Good evening, Pinky. How are you? So let's proceed without making any delay. What we have seen in our yesterday's class, do you remember? Yesterday we have seen binomial distribution, and yes, of course, the binomial distribution is based on Bernoulli's trial. So we have seen the meaning of Bernoulli's trial. We have also seen the non-Bernoulli's trial, under what condition we can apply binomial distribution, and when binomial distribution can't be applied, that situation, what we have to do, that we have seen in yesterday's class. I just wanted to have response from every one of you. I request all of you to hit the like button. Come on, fast. Students, let me introduce myself. Most of you may be knowing about me, but those who are new, students, I have been teaching in this domain since many years, and yes, my subjects of interest are engineering mathematics, analog circuits, and signals and systems. Students, you may be aware of the GATE Aimers series. So this is basically a crash course for EC electrical instrumentation and computer science, and that is already started on 14th of November. You can watch the sessions of your respective branch on the same YouTube channel. Students, once you are preparing for exams like GATE or ESE, you need to assess yourself. For your self-assessment, we have launched the mock test, and that are completely free. So students, you have to just download the BYJU'S Exam Prep app. Yes, of course, our app. And then on that app, you have to enroll for this mock test. So this mock test have already started from 15th of November, and this will be available till 22nd of November. So I request all of you to take this advantage and test yourself in the live national level platform. So students, I just wanted to start Poisson's distribution. Before this, I request all of you to recall what we have done in binomial distribution, when we have applied binomial distribution. Bacha, binomial distribution is applied in case of Bernoulli's trial. Am I audible to everyone? I can see Satyashri, Chandrasekhar, Dreamer, everyone. Welcome to the session. Yes. So all my dear students, we have seen that Bernoulli's trials are those trials in which probability of success and probability of failure remains same in each subsequent trial. Whatever P and Q you obtained for first trial, the same will be applicable for second trial, third trial, and so on. So generally, in case of Bernoulli's trial, we go for binomial distribution. I have used a special clause generally. Why? Because there are some limitations too. Let me recall. When you have Bernoulli's trial, then you need to observe the number of trials. How many times that Bernoulli's trial is repeated? If that Bernoulli's trial is repeated for very large number of times, that is when n is very large, when number of trials are very large, in that case binomial distribution will not converge. Here converge means, will not converge means it will not give you accurate results. Ashok, you'll get both the PDFs today. Okay, no worry about that. So students, when we talk about Poisson's distribution is applied under a very special condition of Bernoulli's trial. In case of Bernoulli's trial, when number of trials are large, at the same time probability of success is small. Number of trials are large, probability of success is small. In that case, we can check whether we can apply Poisson's distribution or not. So all my dear students, see here, if number of trials are very large, probability of success is very small. What does it mean? N tending to infinity, P tending to 0. N tending to infinity, P tending to 0. So in this situation, what you have to do? We will first find N into P. After finding N into P, what you have to do? If N into P is less than or equal to 20, then we will apply Poisson's distribution. And if N into P exceeds 20, then we will apply normal distribution. Got it? So when you talk about Poisson's distribution, what you require? When you talk about Poisson's distribution, you require Poisson's parameter lambda. Once again, I am repeating, when we talk about Bernoulli's trial, in Bernoulli's trial, when number of trials are very large, yeah, it's 20, it's a typing error. When number of trials are very large, in that case, we cannot go for binomial distribution. So what we will do, we'll check whether n is very large and p tending to 0, n tending to infinity and p tending to 0. We will be multiplying these two values and then we'll check n into p. If n into p is under permissible limits of 20, then we can go for Poisson's distribution. Okay, so if capital X is a discrete random variable following Poisson's law. Following Poisson's law means what? N into P less than equal to 20. Yes, Bernoulli's trial for which N into P less than equal to 20. This means it is following Bernoulli. It is following Poisson's law. Then probability mass function P of X equal to, yes, lambda raised to X e raised to minus lambda upon factorial X. This is the format. Students, this is the format. Are you all comfortable? Sir, what is this lambda? Lambda is Poisson's parameter. Sir, how we can calculate lambda? Lambda can be calculated by two different ways in two different contexts. One way to calculate lambda is lambda equal to n into p. Another way to calculate lambda is alpha into delta t. Let you know everything. So comfortable with this? Poisson's law, Poisson's distribution P of X equal to lambda raised to X e raised to minus lambda upon factorial X, where lambda is n into P. Students, you may be knowing that mean of Poisson's distribution is equal to its variance. So mean and variance of Poisson's distribution are equal and they are nothing but lambda. Is that very clear? mean and variance of Poisson's distribution are equal and they are equal to lambda. So this Poisson's parameter is nothing but it is equal to mean or variance. Now moving to the next. Since mean value is nothing but E of x, so E of x is lambda. Also, I can see Saubhagya Nayak responding. Thank you, Vidam. Thanks everyone who all are responding. Variance of x. Variance of x general formula is expectation x square minus expectation of x whole square. So variance x is nothing but lambda. Expectation x square as it is. E of x is nothing but lambda. So expectation x square will be lambda square plus lambda. So this is how we calculate expectation x square in case of Poisson's distribution. This is a very important result. This particular frame is very important for your upcoming GATE exam. And you should not be feeling surprised if you get a question from this frame. Next. I'll come to this question. I'll skip some question, move to another variety, then again coming back to this. Series. If a random variable x has a Poisson's distribution with mean value 5, hello, they have given that mean value, that is lambda equal to 5. Then expectation of x plus 2 square. Okay, so what you can do? You can first find out expectation x square. It is lambda square plus lambda. 5 square plus 5. So expectation x square will be nothing but 30. This is our expectation x square. After getting expectation x square, what you can do? You just think of this value, expectation of x plus 2 whole square. You know how to simplify this? X square plus 4x plus 4. Let us separate this. इनको अलग अलग कर लेते हैं. Four is out and expectation of 1. Now students, expectation x square is 30. Expectation x is given as 5. Expectation 1 is always 1. So what you are getting? Now expectation x square is 30. Okay, this is 4 into 5. So this will be nothing but 54. So we have just utilized the property what we have discussed on that very important frame. This one. If the mean of Poisson's distribution is 2, mean means lambda. Find the second moment about the origin. So students, second moment about origin means expectation of x square. The expectation of x square will be lambda square plus lambda. So we will get 6 as the answer. Expectation x square is nothing but second moment about origin. Come on, respond fast. See this one. If the second moment about origin is 6, it means they have given you expectation x square. We need to find the mean of the Poisson's distribution. Just a logical question. We know that the answer is 2. So lambda square plus lambda is nothing but expectation of x square. Correct? Now lambda square plus lambda equal to 6. So we can factorize this. So here you can see there are two values, lambda equal to minus 3 and lambda equal to 2. But mean can be a negative value, but at the same time this lambda is also serving as variance. Variance cannot be negative. Since variance cannot be negative, this value is rejected and only lambda equal to 2 is selected. Minus 3 is rejected. Why it is rejected? Because this lambda is also representing variance, and variance can never be negative, and that's why we have rejected minus 3. At a very busy traffic intersection, the probability P of an individual car having an accident is 0.0001. So car meeting an accident, let us say it is probability of success P. If 1000 cars pass through that intersection, okay, so how many trials you are taking? 1000. So here we can say that n is large and p is small. When n is large, you cannot go for binomial distribution. Find out n into p. N into p will be 0.1. Arey bhaiya, 0.0001 multiplied by 1000 will give you 0.1. Okay, so assume this to be lambda. And with this value of lambda, we can go for Poisson's distribution. P of x and lambda raised to x e raised to minus lambda upon factorial x. Lambda is 0.1 raised to x e raised to minus 0.1 upon factorial x. Probability that two or more car accidents occurs in a day. What we require? We require probability for x greater than equal to. Arey bhaiya, x denotes the number of car accidents. We require two or more car accidents. It means what? P of x greater than equal to 2. So x equal to 2, 3, 4, this can go up to 1000. It is impossible for us to do this much calculation. So we are just considering the opposite case. Which numbers are left here? Sir, 0 and 1 are left here. So 1 minus. Students, this portion will be common for all the terms. So e to the power minus 0.1 is out. And now you have to put x equal to 0 in this shaded portion. X equal to 0 will give you 1. 0.1 raised to 0 upon factorial 0. This will be 1. Then put x equal to 1. 0.1 raised to 1 upon factorial 1. That will be 0.1. And if you wish, you can further calculate 1 minus 1.1 e to the power minus 0.1. Calculate this, right? Will I get your responses? See this question. This is really a very nice question. Probability for x equal to 2 is equal to 2 by 3 p of x equal to 1. No. Here lambda is not mentioned. Here lambda is not mentioned. So what I will do, I will just assume that lambda is the Poisson's parameter and p of x will be lambda raised to x e raised to minus lambda upon factorial x. So in this formula, I will put x equal to 2. So I will get lambda square e to the power minus lambda upon factorial 2, that is 2. Then p of x equal to 1, put x equal to 1 here. So lambda raised to 1 e raised to minus lambda upon factorial 1 is 1. Okay, sir. Now, students, e raised to minus lambda and lambda cancelled on both sides. I will get lambda equal to 4 by 3. Are you all following? So the very first question, they are asking for the mean and the variance. Arey bhai, mean and variance. For Poisson's distribution, mean and variance both are equal to lambda, and they are nothing but 4 by 3. Then they are asking for probability for x equal to 0 and x equal to 3. So in this format, you have to put lambda equal to 4 by 3 and x equal to 0. So p of x equal to 0 is nothing but e raised to minus 4 by 3. Don't need to calculate this, leave it as it is, as of now. And p of x equal to 3. In this formula, put lambda equal to 4 by 3 and x equal to 3. Four by 3 cube e raised to minus 4 by 3 upon factorial 3 is 6. So 4 cube is 64 upon 27 into 6. Just calculate this. 32 on 81 e raised to minus 4 by 3. I got this one. And the last one, third one, expectation of x square. Lambda square plus lambda. 4 by 3 square plus 4 by 3. 16 by 9 plus 4 by 3. I think 28 by 9 should be our answer. It is known that on an average 0.3% of the results obtained on a computer are not reliable. So they are making a statement by giving you probability of success for not getting reliable results on a computer. So they have made a statement that 0.3% of the results obtained on the computer are not reliable. So generally what happened in earlier days, when some exams results comes out, we used to observe the results immediately on the computer, and it was a belief that if the result is not in favor of us, we just say that result obtained on the computer is not reliable. So anyways, they have made a statement that 0.3% of the results obtained on a computer are not reliable. So P is 0.3%. So this percent means you have to divide by 100. So 0.3 divided by 100, that is 0.003. Find the probability that from a total of 1000 results, it means n, the number of trials is 1000. So n is large, p is actually very small. We can just find out n into p. N into p is very simple, 3 aa jayega, you'll get 3. So by Poisson's distribution, p of x, lambda is 3. So lambda raised to x, e raised to minus lambda upon factorial x. Anji, 3 raised to x, e raised to minus 3 upon factorial x. This is P of X. What we obtain, what we want, exactly two are not reliable. We want probability for X equal to 2. So 9 by 4 e raised to minus 3. Will it work? Is that fine? Next. At the most, 3 results are not reliable. At the most, 3 results are not reliable means X less than equal to 3. Zero, 1, 2 and 3. So students, in this format, you have to put X equal to 0, 1, 2 and 3. So in all the terms, e raised to minus 3 is common. Take it out. When you put X equal to 0, you will get, when you put X equal to 0 in this shaded area, what you will get? Yes, it is 9 by 2. Corrected. Thank you. So when you put X equal to 0, 3 raised to 0 by factorial 0. In this, you have to put 0, 1, 2 and 3. For 0, it is 1. For 1, it is 3. For 2, it is 9 by 2. For 3, it is 27 by 6. Going back, one very important variety. Here, on an average, number of accidents occurring per day on a highway is 3. Okay. So they have made a statement that on an average there are 3 per day. नहीं होना चाहिए, it should be per month. So alpha is number of accidents per month. That is 3. Okay. The number of accidents is following Poisson's law. Find the probability of. Okay, what you need to do, just concentrate here. Alpha is given as 3. See the first case, exactly 5 accidents in consecutive 2 months. It means how to proceed. Alpha is 3, consecutive 2 months. So in the very first question, see the last words, consecutive 2 months. How many units of months are involved here? How many months are involved here? 2 months. So that will be our delta t. That will be delta t. Now what you have to do? You have to find alpha, lambda. Lambda is alpha into delta t. This is another variety. So alpha is given as 3. Delta t is 2. You will get 6. Just formulate the Poisson's distribution. What is Poisson's distribution? P of x equal to lambda raised to x e raised to minus lambda upon factorial x. Now, what you want? Exactly 5 accidents in consecutive 2 months. So put x equal to 5. That's it. This will be our first answer. So this alpha equal to 3 will remain same for all the 4 cases. The universal statement made at the beginning of this. Comfortable everyone? In the second case, they said that a given month. So delta t For second case, delta t is when you see this word given month, it means delta t is 1. Alpha will remain 3. Alpha will remain 3. So lambda will be alpha into delta t. Alpha is 3. 3 into 1. Lambda will be 3. Comfortable everyone? Can I have your response? Have you hit the like button? Now, Poisson's distribution. Lambda raised to x e raised to minus lambda upon factorial x. Now what we want? More than 2 accidents in a given month. So from this Poisson's distribution, I want probability for x greater than 2. More than 2 accidents, x greater than 2. 3, 4, 5. There will not be any upper limit. So this will go up to infinite. But we will opt another way. We will just find out the reverse process. So 1 minus, which all numbers are not there? 0, 1 and 2. So 1 minus. Raised to minus 3 common. See this. In this 3 raised to x upon factorial x, I am putting x equal to values of x. Yes, values of x are 0. 0 will give you 1. When you put x equal to 1, you will get 3. When you put x equal to 2, you will get 9 by 2. Done? So how much you are getting? 4 and a half, 8 and a half. E raised to minus 3. This is our second case answer. Third case. At least 2 accidents in a period of 3 months. So this term. 3 months. In a period of 3 months. It means delta t is 3. Delta t is 3. Alpha is also 3. Alpha is the common statement, right? So lambda will be alpha into delta t. 9. So p of x. Lambda raised to x. E raised to minus lambda upon factorial x. So we have just constructed the Poisson's distribution. At least 2 accidents in a period of 3 months. At least 2 accidents. X greater than equal to 2. So P of x equal to 2, 3, 4, 5 and so on. So 1 minus. Which values are left here? 0 and 1. E raised to minus 9 will be common. Shabash beta. 0. When you put 0, you will get 1, then 9. Very good. Dreamer, very good beta. 1 minus 10 times e raised to minus 9. This will be the answer. Super. Then we have no accidents in a period of 2 months. In a period of 2 months means delta t is 2. Delta t is 2. Lambda will be alpha into delta t. Alpha is 3. So you will get lambda equal to 6. Is that clear? So P of x हाँ जी, lambda raised to x e raised to minus lambda upon factorial x. So no accidents. So p of x equal to 0. No need to solve this e raised to minus 6. It will be very small value. So we have done it. The average rate of phone calls received is 0.7 calls per minute. So alpha is given 0.7. Okay. In the very first case, there will be at least one call in a minute. One call in a minute. So in a minute. So delta t will be 1. Lambda will be alpha into delta t. 0.7 into 1 will be 0.7. P of x. Lambda x raised to x e raised to minus lambda upon factorial x. Lambda is 0.7 raised to x upon factorial x. X. There will be at least one call in a minute. There will be at least one call in a minute. X greater than equal to 1. Just think of the opposite. 1 minus p of x equal to 0. That's it. Put x equal to 0 here. You will get e raised to minus 0.7. Third one. Second case. There will be at least 3 calls during 5 minutes. See, during 5 minutes means delta t is 5. Lambda will be alpha into delta t. Alpha is 0.7. 0.7 into 5 will be 3.5. Okay, sir. So p of x. Lambda raised to x e raised to minus lambda upon factorial x. What we want? There will be at least 3 calls. It means we want x greater than equal to 3. What is opposite case? 0, 1, 2. So 1 minus p of 0, 1, 2. So this e raised to minus 3.5 is out. Put 0. 3.5 raised to 0 by factorial 0 is 1. Then 3.5 for x equal to 1 and 3.5 square by factorial 2 for x equal to 2. Need to just calculate this. Let me know the answer. That's it. That's all from my side in this session, students. I'll just share my Telegram link here. This can be your homework question. You need to post the answer of this here as well as in my Telegram group. Meanwhile, you can hit the like button if you have not done so. I'll share my Telegram link with you. Tomorrow we are going to discuss about normal distribution. So all of you must be present. Normal distribution. I hope you all have enjoyed today's class. Say yes or no. So in the description box, many such very nice information for you. So GATE preparation free ebook is there. You can download it. Free GATE workshop. You can register for it. Thank you, beta. Telegram link is already shared. Check it in the comment box, beta. Thank you. Jai Hind, Jai Bharat. We'll meet tomorrow at 5 p.m.